Hi everyone, welcome to G World of Academic Physics. Today we will discuss one of the applications of electric field, that electric field on the axis of a ring. So let me derive the electric field on the axis of a ring. I am considering a ring, a charged ring. This is my charged ring. Charges, a Q charge is uniformly distributed on the ring. This is my ring of radius r, and Q charge uniformly distributed on it at a distance. This is the axis of the ring. This is my axis of the ring. At a distance x, I said, from the center of the ring, a point P is exist here. And what is the expression of electric field at point P at a distance x from the center of the ring? That expression we need to find. So what is the question is here? Find the expression of electric field at a distance x from the center to this point P. The expression of electric field on the axis of the ring. When this kind of questions has given to you, any extended object have been given to you, what is the basic thing that we have to be in your mind? That we must consider a small element. So this is my element. In this element, the total charge is what? dq. And this small element exactly at the top section of the ring. And what I draw here? I draw the distance. This is r, this is x. Can I say this is r square plus x square root over? Yes, this distance is r square plus x square root over. Due to this dq charge, total charge is q. I consider a very small element. In this element, charge is dq. And I said this angle is theta. This is positive, and at this point I need the expression of electric field, so I will bring a test charge is here. This is positive, so it will definitely repel like this. If this angle is theta, can I say this angle is theta? Yes. So due to small element, whatever the expression of electric field is come, can I say a small electric field will come? If this is theta, so this is, I can say this is d cos theta, and this is dE sin theta. If this is my dE vector, there will be two components of the vector, that is dE cos theta and dE sin theta. Similarly, if I consider a very small element here, and I will connect like this and making this angle as theta, I can think this is dq now. Positive, it will repel like this. So how many components? There will be two components. This is dE sin theta. If this angle is theta, this angle definitely theta. And this is what? dE cos theta. So what is the important thing we observed here? This dE sin theta and dE sin theta are equal in magnitude, but in opposite direction. These two components have cancelled each other. There will be net electric field, and that will be in the direction x directions. This is dE cos theta, dE cos theta. Student usually, what the mistake student usually do, they adding this dE cos theta and dE cos theta. No. And they write usually 2 dE cos theta. No. This is an extended body. So in case of an extended body, it is not two individual things that we are treating. This is the same part of the body. So rather than adding, we will only write the net is dE cos theta. If it will be two different charges, then we can say that this is dE cos theta, dE cos theta, and the net is 2 dE cos theta. But this is the same part of the body, so I can say the net electric field is dE cos theta. This is the small electric field. So if I want to find the net electric field at this point, can I integrate this dE cos theta? Yes. Due to this small element, what is the expression of electric field? This is dE cos theta rather than 2dE cos theta, because these are this is the extended body and these two are the part of the extended body, not two different things that we are talking about. So dE cos theta. For a complete body, what is the net electric field? So I can do the integration technique and I can write as dE cos theta. What is dE? Can I say kq upon r square? K, this is dq, upon r square. This is nothing but r square plus x square whole square, like this. And what is cos theta? Cos theta, if you look at this diagram, this is x upon these things. X upon r square plus x square root over. So what is, and integration is here. And if I proceed like this, I will reach kx upon r square plus x square whole to the power 3 by 2 integration of dq. If all dq integrations are nothing but the summations, if I add all these small dq, all these sections, I'll get the total charge as q. So can I write like this, kxq upon r square plus x square whole to the power 3 by 2. This is the expression of electric field on the axis of a ring at a distance x. This is very important result. Please in your mind that kqx upon x square plus r square whole to the power 3 by 2. Now little important things in the competitive point of view. The question can be asked you, find the point where electric field is maximum. Electric field is what? Maximum. So using, if the concept is asking that maximum, little spelling, yes. If the question is asking find maximum or minimum, we are going for the concept of differentiations. So here x is variable. So what I will do, this question is asking maxima or minima. I'll think like that, d upon dx equals to 0. And I will get that point, making it equals to 0, I'll get that point where the electric field is maximum. Look at this point, do the derivatives. I will do the derivatives with respect to x. K q x upon r square plus x square whole to the power 3 by 2 equals to what? 0. So what I will do, I will simply do the derivative. K q are the constant, so d upon dx x upon r square plus x square whole to the power 3 by 2 equals to 0. These constants are outside here and making 0 this side, I'll get it, this thing is 0. It is the rule, I can say u by v, the division differentiations rules I can be used. Derivative of first into second minus derivative of second into first upon, this is upon v square. So it is just like this, you can think like this, u by v, derivative of u by v is just derivative of u into v minus u into derivative of v minus v square. This is a simple mathematical technique that we are using. Now do that. Derivative of first, derivative of with respect to x, that is derivative of x is what? 1 into what? R square plus x square whole to the power 3 by 2 minus first x into derivative of these things, derivative of x to the power n, this is 3 by 2 r square plus x square, this is 3 by 2 minus 1 into 2x upon what? R square plus x square, 3 by 2 square, that will give 3 equals to 0. Please look into the mathematics. Basic mathematics have been included here. A student must be very aware about the scenarios. These are the basic mathematics. If this thing is 0, this will be equal, this will be multiplied to 0, giving rise to 0. So what is the final result is coming as r square plus x square whole to the power 3 by 2. Here 2 cancel, and it is coming what? Minus 3x square r square plus x square. This is 3 by 2 1. This is coming as 1 by 2. I hope this result is, this is equals to what? 0. So this is coming r by 2 plus x square equals to what is coming? 3x square. And this is what? 2x square equals to r square. X square equals to r square upon 2, and x is coming plus minus r by root 2. This is very important result a student must be adding in the checklist. At what point the electric field will be maximum? Exactly at r by plus minus r by root 2. If I want to plot the graph of electric field with the distance, little carefully, student must plot this graph. This is my electric field, and this is my distance x with respect to E versus x graph, because here x is varying. I can take x here, I can take x here up to this distance, I can take x anywhere. One can predict the conclusion, very important. When I'll put x is 0, this is very important. When I'll put x is 0, when x is tends to 0, put here x is 0, that electric field is coming to 0. It means when x is 0, electric field starting here. When x is tends to infinity, we just put the infinitive here, and you will get the net electric field where it will come to 0. At infinity, it is also coming to 0. The electric field is coming at x equals to 0, the electric field is 0, and it is infinity, it is coming to 0. And the maximum value is r by root 2, and the maximum value is what? R by root 2. So how I will plot the graph? This is very important. So 2 point, the field is 0, one is here, another one is infinite, it will come to 0. It will be go like this. And what is the maximum value? That is x equals to plus r by root 2. And where it is 0? At 0 at origin, as well as at infinite the field is 0. Similarly, the pattern I can draw, it will be go like this, and this is what? X equals to minus r by root 2. This is the nature of the graph. The student must be very aware. In the NEET paper, I have seen this kind of questions as asked some previous NEET models. And if someone will ask you, what is the maximum value of electric field? We know the expression of electric field is these things, and we got the x equals to plus minus r by root 2. The electric field is maximum. So what I will do, simply I will substitute the value of x equals to r by root 2 in this equation, and x value here and here, I will get the maximum electric field. If I'll put the maximum value of x in these expressions, so we'll get the maximum electric field. Just put it. This is k. What is x value? This is r by root 2, and this is q upon what? R square. This is r square upon 2. If I'll put it here, this is 3 by 2. And if I'll solve these things, this is coming k r by root 2 q upon this is what? 3 r square by 2 whole to the power 3 by 2. So expression is coming k q upon r square, here square r q. So this is r square, and what is the expression is coming? And this is 2 goes upward, so 2 upon 3. This is 3, and yes, 3 root 3. This is the expression of electric field, maximum expression of electric field, it is coming. And how to remember these things? Student have to remember this mathematical value 2 upon 3 root 3. And you know the expression of electric field due to a point charge like kq upon r square. If you want to remember, just write the electric field due to a point charge, that is nothing but kq upon r square, that we all know, and remember the value 2 upon 3 root 3. That can be help you a lot. Let me summarize what I did here. We are finding the expression of electric field electric field on the axis of the ring. Let's consider a ring, total charge is q. I consider a very small element. Let x be a distance from the center of the ring to point P, where we need to find the expression of electric field. I consider a very small element. Using the vector component methods, I find the net electric field due to the small elements. This is dE cos theta. After that, the total electric field due to the small elements, can I do the integration technique? Yes, I can use the integration dE cos theta. And writing the electric field due to a point charge, what is the expression? This is dq, this is q naught, this is dq, this is q naught. I simply write the expressions here and cos theta value here. Solving this method, we'll get the electric field is kqx upon r square plus x square whole to the power 3 by 2. Second most important thing is find the point where the electric field is maximum. When this question of maxima and minima is asking, you must do the derivative and make it equals to 0 using that u by v derivatives, and I reach a very conclusive result that x equals to plus minus r by root 2, the electric field is coming to 0. And I plotted the graph nature. When e tends to 0, x tends to 0. When e tends to 0, x tends to infinity. It means when x tends to 0, the field is 0. When x tends to infinity, the field is 0. And where it will be maximum? R by root 2 and minus r by 2. So this will be definitely the nature of the graphs. And if you substitute this maximum value of x, you will get the maximum electric field, and the expression is coming like this, a point charge expression with some mathematical value 2 upon 3 root 3. I hope the scenario is clear to everyone. Thank you everyone. Thank you for your watching.